Assalamu alaikum, dear students. Hope all of you are fine. This is the continuation of A2 chapter 12, motion in a circle, and this is the lecture number 3. And here we will talk about the centripetal acceleration and centripetal force. According to definition, very simply, you can define the acceleration of a body moving in a circle. So it's very simple definition. The acceleration of a body moving in a circle is the centripetal acceleration. Here actually we have to recall which we have already studied, and if like suppose we are considering a body which is moving in a circle, then the situation is, here suppose we have a body which is moving in a circle and the center is O. So we can say that here we have the velocity, and after some time the body will be here from point O to O dash, and we can say that the of course velocity has changed direction. Now as we have discussed before as well, that velocity or linear velocity, if you are using the term linear velocity, so this is the speed and direction, or simply you can say that the linear velocity is a vector quantity. So it will have two parts. One is the magnitude of the velocity, and here we have the direction. You know that vector quantity has both of these two things. So here we have the direction, and this is the magnitude, which is termed as the speed. So if we are talking about the magnitude of the velocity, so we can say that this is the speed. And if a body is moving in a circle with uniform speed, then of course the motion is the uniform circular motion. Now the thing is that when we are talking about the linear acceleration, simply linear acceleration is the rate of change of velocity. Here very simply you can recall that if you have a body A, suppose, and this body is moving with initial velocity u, and after some time suppose the velocity becomes v, so what we can say that the change in velocity is v minus u. So if you want to know the rate of change of velocity, which is basically the acceleration, here you have the acceleration, so the change in velocity is v minus u, and of course this change of velocity occurred in a particular time interval. So if that time interval was a t, and you are dividing this v minus u by t, then you are getting the rate of change of velocity, which is nothing but acceleration. So in this case we can say that the acceleration is because of the magnitude change, yani change of magnitude of the velocity, or simply you can say that the speed has changed from position A to position B. So this is what we have as far as the linear velocity is concerned. In case of your uniform circular motion, you know that the acceleration is not because of the change in the magnitude. Yani, of course, when you are talking about the uniform circular motion, the speed is constant or magnitude of the velocity is constant. So there is no change in the magnitude of the velocity, but the change is because of the change of the direction. So it means that if you will consider this particular diagram again, you will say and see that here we have one value of velocity, here we have another value of velocity, but this change in velocity is not due to the change of magnitude. And you know that we are considering the uniform speed, so the magnitude of the velocity is constant, but the change in direction is taking place. So at this position you have one direction, at this position you have another direction. So of course the change in velocity is not because of the change in magnitude of the velocity, but this is because of the change in direction of the velocity. So this is the difference between the linear acceleration and the you can say the acceleration in case of your body moving in a circle with uniform motion. So another point which is very important to recall and remember, that acceleration is not always in the direction of velocity. So this is very, very important actually. Acceleration is not always in the direction of the velocity, but it's always in the direction of change of velocity. What these lines are actually telling us. So just go back to this example where we are considering here that body is at point A, after some time the body is at point B. So what is happening? The change in velocity from U to V is in the direction or in the same direction as the, you can say, the velocity for the time being. The change in velocity is here. This is the change of velocity, the direction of the change of velocity, and the acceleration is also will be in the same direction. So this is very, very important. But if suppose you are talking about the retardation where the change in velocity is in opposite direction or negative change of velocity, you can say, then you know that the acceleration, any negative acceleration or retardation will be in the direction of the velocity. So this is very important. Yani the acceleration is not always in the direction of the velocity. Yani in this case, the velocity is still here, yani from point A to point B, velocity is here. But the change in velocity is in the opposite direction, and in the same direction you will have your acceleration. So this is very, very important concept, and you have to remember this thing, that the acceleration is always in the direction of the change of velocity. So this is very important. And in case of the circular motion, the last point which we have to mention here is that in case of the circular motion, you know that the change in the direction of velocity is always towards the center of the circle. What does this mean? If we will go to the next page, then we can find here that what are the situations of your you can say the equation. But before going to the equation, what I have just told you in the last point here, this is very important. In case of circular motion, the change in the direction of the velocity is always in the direction or towards the center of the circle. So to understand this, we have to consider this velocity vector somewhere here outside the you can say circle. I am just considering that you can say that this is our V, and after some time the velocity is a V dash. So the change in velocity is towards the center of the circle. So this is the direction of the velocity, and as I said before, that this direction or you can say the velocity change is not because of the magnitude but direction of the velocity, and you can say and see that it is always towards the center of the circle. So you can say that the acceleration in this case is always towards the center of the circle, and this is the centripetal acceleration. So again, if we will go back to this concept, that in case of your linear motion, the change in velocity is because of the change of magnitude, and we have this simple formula. But when we are talking about the change in direction of the velocity, then of course the formula we cannot apply as we have written A is equal to V minus U divided by T, but we have a new formula here which is AC is equal to V square over R. AC is equal to V square over R. This is our formula, and you have to remember this formula. Actually, we can derive this formula as well, but you need not to derive the formula. Just remember this formula, that AC, yani C is for centripetal, C is for centripetal, and of course A is for acceleration. So AC means that you are talking about the centripetal acceleration. So centripetal means what? Central seeking. yani towards the center of the circle. As the above acceleration always towards the center of the circle, we call this acceleration as the centripetal acceleration, as I just told you. And as I said that it is always towards the center, so simply you can use the term central seeking. So this is very, very important. Yani central seeking acceleration is centripetal acceleration. And what you have to remember is that in this case, in case of centripetal acceleration, the acceleration is not because of the change of magnitude of the velocity, but this is because of the change in direction of the velocity. And of course, because of this, a new equation we have to use, which is simply A is equal to V square over R. You have to actually remember this formula. As I said, we can derive this formula as well, but in your syllabus we need not to go for the derivation. Where we need derivations, then we inshallah we will do the derivations as well, but for the time being it's not required. Here, as I said before, that in the beginning of the chapter we have discussed certain, you can say, few formula, and one of the formula is V is equal to R omega, where V is the linear velocity, omega is the angular velocity, and of course R is the radius of the circle. So again, here we have the situation of a body which is moving in a circle, and as you have developed or you have written the formula for centripetal acceleration as V square over R. So in one case you may have the value of velocity and value of radius given, but in another situation you may have the value of radius and value of omega given. So you want to develop another equation instead of driving this or developing this equation when you are sitting in the examination hall. You better do all these steps here and remember these formulas, and of course we will practice some questions as well, and these few questions will give you the idea that what is the situation of the equation when we have a given condition. So here, as you know that VAC is equal to V square over R. So instead of V, when you will use this value, V is equal to R omega, or the equation V is equal to R omega, then you will get this formula in this way, that R omega whole square divided by R square omega square divided by R, and ultimately you are getting R omega square. So it means that the second form of the equation is AC is equal to R omega square. So the first equation, AC is equal to V square over R. Second equation which we have developed is AC is equal to R omega square. Then you can recall this equation as well, that the omega is nothing but 2 pi over T. So when you are talking about 2 pi over T, you have another you can say replacement, and you can write in this way that AC is equal to R omega square. So instead of omega square, you are using 2 pi over T, and when you will use this 2 pi over T, you will get R 4 pi square T square. So simply you can write 4 pi square R divided by T square. So another form of the centripetal acceleration is this one. Yani if in one problem the time of suppose rotation is given and the radius of the circle is given, and you need to calculate the centripetal acceleration, then very simply you will use this formula. Of course, you need not to go to this formula or this formula. So this is the third form of the same thing, any centripetal acceleration we can write in this way as well. Then we have another situation, and we have been talking about the time period, and of course the relation of time period and f, yani frequency, is given as f is equal to 1 over t or t is equal to 1 over f. So over here, as you have in the last equation, AC is equal to 4 pi square R divided by T square. So simply you can also write that 4 pi square r into 1 over t square. So simply it means that if you will replace this equation in terms of frequency instead of time period, so the new formula will be AC is equal to 4 pi square r f square. So here again, if the information or data is given as you can say the radius and frequency, then the centripetal acceleration, if you need to calculate, you can find out the value with the help of this formula, which is the fourth one or the fourth form of the formula. So all these are actually the different forms of your centripetal accelerations, and you need not to worry about these equations. I have developed this equation just because you should know these equations before going to the exam, and of course you must be able to solve problems according to the given data. Simply again, if you want to write or summarize this whole situation, you can say that we have discussed these four equations, and these four equations are basically, again we are writing, and as I said that this is the summary 1, 2, 3 and 4 equations for your centripetal acceleration. And again, as we have already discussed this thing, that the centripetal acceleration is the acceleration toward the center of the circle, and this is because of the change in direction of the velocity and not because of the change of magnitude of the velocity. So this is very important. Another point, if you will recall, and I think you can very easily recall that F is equal to ma we have studied. It means that whenever we will have the acceleration, we will talk about a force, and this is because or according to the Newton's second law of motion, that acceleration is always directly proportional to the resultant force and in the direction of the force. So if you will talk about the acceleration, then of course you can talk about the force, which is the you can say reason of the acceleration, or which is which is causing the acceleration. So acceleration is always because of the force. In this case, this force is called the centripetal force. It means that now we have moved from the centripetal acceleration towards another term, which is the centripetal force. Here again you have to remember the same thing, that the centripetal force or whatever the force you have, always, as I have discussed in the previous part, that the acceleration is due to the change of the magnitude of the velocity in case of linear motion, and acceleration is due to the change in direction of the velocity in our circular motion when the speed is constant or uniform. But the thing is that here what we are saying, that whether we are talking about the linear or angular situations, acceleration is always in the direction of the force. So again the same thing, if you are suppose considering these two you can say positions of a body from A to B, the force is in the direction of the change in the magnitude of the velocity, and of course you can say that the acceleration is v minus u divided by t. This is the linear with the acceleration, and we know that the force and accelerations are in the same direction, yani you can say in the direction of the change of velocity. So this is what we have. Again you can say that the acceleration here, the centripetal acceleration, is because of the force, which is always towards the center of the circle, and this force is called as the centripetal force. Excuse me. The force which moves a body, here you have the definition. The force which moves the body in a circle is always perpendicular to the velocity and acts always toward the center of the circle, and this is the centripetal force. So this is what we have. As far as this force is concerned, as I said, that this is always in the direction of the acceleration, or acceleration, which is the centripetal acceleration, will be in the direction of the centripetal force. Here you can use another concept, like if you are talking about the work done. So what is work done? From point A you have moved to point B and the displacement is D. So you can recall the definition of work done, and this is force into displacement in the direction of the force. So this is work done here. So if you will talk about, suppose, the vertical work done, then of course you can say and recall that force you have to apply will be at least equal to weight of the body, and this is mgh. So the simple formula is fd, but you can of course write the work done in this way as well. But what actually the point is, the you can say the work is when we have moved from one position to another position. But when you are moving in a circle, as there is no displacement from the center, meaning you are moving in a circle and the radius of the circle is fixed or constant, so there is no change in the displacement. So simply you can say that the situation is that the no work done we will have when we will have a fixed type of radius or fixed radius or constant radius. So centripetal force, what we are writing here, centripetal force will not do any work when the body is moving in a circle of a fixed radius. So this is something which you have to remember. This is very important point as well. Now if you have understood this centripetal force, and I think it's not very difficult, so we can now go for the equations of the centripetal force. And again the same thing according to the Newton's second law of motion. This is Newton's second law of motion, which is giving us this formula, F is equal to ma. Yani if you have a body of mass m and the acceleration is a, so of course F is equal to ma. Same will be the case in this discussion. And if you are talking about the centripetal acceleration, then the force will be centripetal force. So very simply what you can do, the equation which you have developed over here, 4 equations you can use instead of AC, and you will get the you can say different forms of the formula. Like you can have the V square over R first of all for AC, so mv square over R. Then you will have the another situation, AC is equal to AR omega, so your FC is equal to mR omega square. Similarly, as we have developed the formula for AC in terms of radius and your time period, then the centripetal force will also be given in terms of radius, time period, and of course here you have mass as well. So the mass multiplied by radius divided by t square. So this is another formula which is very simply you can develop. The concept is same, and the concept is that F is equal to ma. And what we are doing here, as FC we are considering, so all AC formulas we can use, and ultimately you can say that FC is nothing but 4 pi square mR F square, when you will replace your AC by 4 pi square R F square, which you have developed in the last discussion. So these are again 4 equations. Very simply again you can, if you want to write, you can write that FC is equal to mv square over R, FC is equal to mR omega square, FC is equal to 4 pi square mR, and over here you have the t square as well. So this is what you can write, and this is something, of course R square will be here, R square, because when you will write the formula of omega square, you will have the R square, and ultimately you can write the formula in this way. And you can I'm sorry, this is basically only R here, 4 pi square mR divided by t square. So this is not square here, and 4 pi square. Then the fourth formula is Fc is equal to 4 pi square mr f square. So these are the formulae for your centripetal acceleration. Why we have developed these formulae? Answer is very simple, because if the data is given in one form, then we can use the one form, or you can say the equation, and if the data is given in another form, then we can use another equation, and so on. Last but not least, for the time being, I just want to mention here that centripetal force is not a new force. Now this is something which is very important, but sort of confusing sentence as well. Centripetal force is not a new force. What does this mean? You know that we have different, you can say, examples of a body moving in a circle, like suppose from electron to which is revolving around the nucleus in an atom, to the moon and earth, or earth and sun, and a big you can say bodies. And in each and every case we will consider the centripetal force. Like suppose here, if we are talking about the electron is moving around the nucleus, because there will be electrostatic force. So we will not say that there is an electrostatic force between the electron and the proton and there is a centripetal force, but simply you can say that electrostatic force of attraction between electrons and nucleus, or electrons and proton, is giving us the centripetal force. So in this case, the electrostatic force between electron and proton is acting as the centripetal force. So this is very important. Yani force is already existing here, but what we are saying, that this force is acting as the centripetal force. Similarly, if you are considering the example of moon and earth, then you know that there is a force of attraction, which is the gravitational force between moon and the earth, and this is the force which is acting as the centripetal force. Similarly, if you are here and you have a string with which you have tied a body of mass m, and you are moving the body in a circle of radius r, of course the centripetal force will be towards your force which you are applying, and this is your centripetal force. So simply you can say that the tension in the string, the tension is because of your force. So you can say the tension in the string is the centripetal force in this example. So number of examples you have where the bodies are moving in a circle, and accordingly you will consider the centripetal force. Last but not least, here you have another example where you have a body and you have a car which is moving in a curve, and the road is a curved road and the body is taking a turn. So what is the friction, you can say centripetal force, and where is the centripetal force? So here you have the situation that to understand this particular example, we are just considering, suppose I am just asking you that if there will be oil on the road, what will happen? If there will be oil on the road, what will happen? So simply you can say that the car will slip or skid and will hit somewhere here. But if the car is taking a turn, it means that there is a frictional force between the tires and the road. So this frictional force between the tires and the road is here, and this is the force which is acting as the centripetal force. So in this case, the frictional force between the tires of the car and the road is acting as the centripetal force. So this is what we have. For the time being, I am just stopping this discussion here. Hopefully you have understood this topic. Two topics actually we have discussed today. One is the centripetal acceleration, and in the continuation we have centripetal force. So hopefully you have understood the discussion, but if you have any confusion, kindly give me your questions through your comments, and when I will see the comments, I will give you the answers as well. And if you are new on the channel, subscribe and like and share this channel so other students can also get benefit of this discussion. So hopefully you are understanding what we are discussing here. As I told you before, that this is chapter number 12, motion in a circle of A2, and of course this is the third lecture of the discussion. So this is what we have. Inshallah, in the next lecture we will discuss few examples of your centripetal force, and we will see that what type of equations we can apply over there. So till the next lecture, Allah Hafiz, take care.